Hello everyone, it's Psi time for grade 8, unit number 6, magnets. This is lesson number 1. So have you seen magic stones? Look at this picture. So you will say there is no magic in it. Actually this was kind of a wonderful thing, and it was a magic to the ancient people. But now we know that there is kind of reason to attract these iron rings. How does it attract iron rings? Yes, they have magnetic properties. This stone contains some magnetic material that may be the reason to attract that. The ancient people said such stones as lodestones. Now we have made magnets out of them. Look at this. Can magnets attract anything? Can they attract anything? Let's find this with these materials. Paper clip, yes, usually paper clips attract to the magnets. What about gold rings? No, it doesn't attract. And then aluminium foil, not attract. So a coin, it is made of copper, does not attract. And iron nail, yes, it attracts. So then graphite contain carbon, does not attract. Finally, rubber eraser, never, it doesn't attract. So only two things attracted, that is paperclip and nail. Both are made of iron. We will have another question here. The question is whether they attract only iron. Do magnets attract only iron? This time answer is no. There are three metals showing magnetic properties. They are this one iron, that's what we discussed just before. And there's another one, this rim is coated with cobalt. Yes, cobalt also attract to the magnets. Then nickel. This zinc is plated with nickel. Nickel shows magnetic properties. So three metals show magnetic properties: iron, cobalt and nickel. And non-metals never attract to magnets. Let's move on to the next. Is there a limit to a magnet's power? We can reveal this by a simple activity. Look at this activity. Yes, here there is a bar magnet kept on a white paper, and we will cover this bar magnet with a plastic lid here. It's transparent lid. This time we spread or sprinkle some iron filings on it. See this, sprinkling iron filings. So what happens here? Some iron filings attract to the magnet, some remains as a pattern, and some does not attract and remains away from the magnet. So this is the final result, and in this also we can clearly see in two zones the iron filings gather with more concentration, more amount gathered in these zones. Let's see more clear picture here. Now see this picture. This is one end and this is the other end. Then iron filings gather more around these two ends. We call these ends as poles, poles of a magnet. Poles are the strongest areas of a magnet. The middle of this magnet center is the weaker zone. And magnetic strength, these lines shows us the magnetic field. It's called magnetic field. Then some filings here does not attract to the magnet. That means magnetic field or the magnetic zone has a limit. So the answer is there is a limit to magnet's power. And these poles have two names. One pole is called South Pole and the other pole is North Pole. Let's see how different magnets have their poles or how they have magnetized. U magnets magnetize as north and south pole exist like this, right? U magnets diametrically magnetize like this. Bar magnets also magnetize as the magnetic or the poles comes to their ends. This is how the bar magnets magnetize. Horseshoe magnets also similarly magnetize, but this horseshoe magnet shows the north and south pole with colors, and in this one it's not shown. Look at this one, ring magnets. Some are axially magnetized, some are diametrically magnetized. Look at the button magnets, also similar. Some button magnets have axial magnetizing and some magnets magnetize diametrically. And next one, tape magnets. Tape magnets magnetize alternatively. That means north, south, alternatively we can see in tape magnets. So with this part we will finish our lesson 1 of the magnets unit, and we will meet back from the lesson number 2. Till that, goodbye.